Dear students, the topic for today's lecture is on linearity. Today, we will discuss about the concept of linearity. What is linearity? What is a linear system? What is a non-linear system? Okay, and what are the conditions for a system to be linear? So this lecture covers the analysis of the basic idea of linearity. It discusses about the principle of superposition, and it also discusses about the concept of homogeneity and additivity. Now, what is linearity? As you can see, linearity is basically a property. Generally, what we think that if the behavior of any system is indicated by a line. So we say that the relationship between these two variables f, y and x, where y is the function of x. So here x may be your independent variable and y is the dependent variable, right? Y is the dependent variable. So when the characteristics of any system are represented by a straight line, so we say that the given system is a linear system, or we can say that the system can be expressed by the linear equations, right? The equations are the linear equations. So but there is one question, one doubt, that let us say there is a system which has two parameters, y and x, and you have the mathematical relationship like this. So this is a intercept basically. So whether this system is linear or not, question mark. Whether it is linear or non-linear, that is also we will discuss, right? So linearity can be understood through mathematical equations, through graphical representations, right? But that is a different thing. However, there has to be a condition, and there is a condition for any system to be linear. Any system can be linear only when it possesses two properties. One is the homogeneity property, which is also known as scaling property, and the second one is additivity property, right? So if a system possesses, or if a system has these two properties, only then we will call such system as a linear system. However, the additivity property itself is known as superposition, right? Now, what are these properties? What is the homogeneity property and what is the additivity property that we will discuss in next slides? Okay. So in our electrical systems, we have resistors, we have capacitors, we have inductors. All these are linear elements because they all possesses scaling property, right? They have this scaling property. Now, what is this scaling property? Right, that we will discuss. So let us come to the property of homogeneity first. Homogeneity property is also known as the scaling property. Linearity sometimes is also understood as scaling. For example, For example, if you have a parameter y, if you have a parameter y, and which is, let us say, equal to some x, right? Let us say it is y1 and x1, for example, and there is one more parameter y2, which is, let us say, equal to ax2. So what you have done, you have scaled this particular parameter. However, you can also say in both the cases, here the scaling factor is 1 basically. The scaling factor is 1. And here the scaling factor is a. So you can say that y1 is proportional to x1, and you can say y2 is proportional to x2. So that means somewhere, somehow, a linearity is related to the proportionality also. Okay. What is scaling basically? Scaling is magnifying a quantity with a certain factor, increasing or decreasing a quantity with certain factor, certain value, right? This is what scaling is. So in second case, you have magnified the parameter y with factor a by multiplying a with x2, right? So scaling property itself is known as homogeneity property, and linearity is understood as scaling sometimes or most of the times, right? However, we have since one more property which a linear system has to follow or obey, okay, so that we will also discuss. Okay. Now, what is homogeneity basically? What is homogeneity? Homogeneity has come from the word homogeneous. Homogeneity has come from the word homogeneous. Now, what is homogeneity? So, homogeneity is basically the property by virtue of which your system has some input and it has some output also. Now, when we say excitation, we actually mean to say the input. We actually mean to say input, right? For example, there is a system. Let us say this is a system. It has some input. It has an output, right? So input is known as excitation. Like when you want to turn on the fan, so what you do? We switch on. Let us say it is a fan. So you give input as voltage or current, and what you get is RPM. So if you increase current, you have a regulator. Just remember one thing. This is the best example. Regulator. Okay. So there may be a regulator. Right? There may be a regulator. What does a regulator do? A regulator regulates the speed of a fan. Okay, you have fan installed at your house, in your room. So when you vary or when you operate a regulator, what it does? A regulator is something like this, a rotating part. It has like 0 and 1 and 2 and 3 and 4 and 5. 0, 1, 2, 3, 4 and 5. And it has a knob. So when you move a knob from 0 to 5, what actually you are doing? You are decreasing the series resistance. Okay, what does it mean? Because your regulator is nothing, is a variable resistor. It is a variable resistor, right? So let us say you have a supply, AC supply, you have a regulator, which is a variable resistor. So this is the symbol for variable resistor. And then you have a fan, which is a load. So there is a switch also. So when you turn on the switch, from 0 to 5, you have a range of the regulator. So from 0, if you move from 0 to 5, if you move from 0 to 5, right? So from 0 to 5, fan speed increases. From 5 to 0, sorry, decreases. What decreases? Fan speed, right? Fan speed decreases. Okay. So what actually you are doing when you are moving from 0 to 5 or 5 to 0, what actually you are doing? You are, we are varying the current to the fan by varying the variable resistor, that is regulator. By varying the regulator, you are varying the resistance. Okay. Now, what actually is happening? Agar, if you have understood this thing, what is this scaling property is? What is the scaling property? So when you move from 0 to 1, okay, speed increases. From 1 to 2, speed further increases. That means what you are doing actually, you are scaling the current. Okay, what we are doing, we are scaling the current. And in the same proportion, basically, the speed of fan is increasing. And similarly, when you decrease the resistance from 5 to 0, 5 to 4, 4 to 3, 3 to 1, 2, 2 to 1, 1 to 0. So what you are doing, you are decreasing. You are also, you are descaling the current. You are reducing the value of current in some proportion, constant proportion, right? And the speed will decrease in the same proportion. So this is what scaling is. So you have a system, guys, you have a system, and that system has certain input, it has certain output also. Input we call as excitation. Excitation means uh, some energy given, some current given, or some voltage given to the system, right, so that it can operate. Okay, so you have a system, you have output, which is also known as a response. You have the input, which is also known as excitation. So this is the system, right? Now, now remember one thing. Let us say X is the input and Y is the output. So if X is multiplied by some factor A, the output shall also be multiplied with the same factor. So scaling is basically multiplication, multiplying the quantity with some factor. That is, if y is equal to x and you multiply x with a, then y shall also be multiplied with the same factor. Means, what I mean to say, that your output shall also increase with the same. If input increases with certain value, output should also increase in same proportion. If input decreases, output shall also decrease. This is what scaling or homogeneity property is. So let us read this line. Let's read these lines. Homogeneity requires that if the input of a system is multiplied by a constant, then the output should be obtained by multiplying the same constant to obtain the correct solution. So let us understand this with an equation, and the equation is, let us consider an input x and the output y. Then mathematically these can be related as y is equal to fx. So y is equal to fx, where f dot is basically a function. What I mean to say, that y is the function of x. Y is the function of x. Right? Now, if you multiply x with some factor a, if you multiply x with some factor a, so now your function has become f of ax, function of ax, right? Okay, scaled matlab means multiplied. Right? So you have the output ay. So if fx is y, so f of ax means when you have multiplied x with a should give you ay, right? Okay, so this is what scaling is. The best example, another example that you can read or you can use to understand scaling. For example, if there is one notebook which costs you 10 rupees, so if you purchase 10 notebooks, it would cost you 100 rupees. So 10 into 10, scaling has been done. So this is what scaling is. This is what homogeneity is. So if any system, guys, follows the property of homogeneity, property of scaling, okay, so we will say that this system is a linear system. This system is a linear system. Now there is one more condition for any system to be the linear system. Okay, and the second condition is homogeneity. Okay, so this is the test for homogeneity, right? Now this is a short numerical given here. For example, you have an equation y is equal to 4x, right? Y is equal to 4x. We will try to understand from here. So if you draw a graph of this particular equation, so the graph will be like this. So let us draw a graph here. So let us have a table y and x. So if x is 0, y is 0. If x is 1, y is 4. If x is 2, y is 8. If x is 3, y is 12. Right? So now if you draw this, you will have a line like this because at origin both are 0. So this is what linear system is. This is a linear system, right? Now, so here the principle of homogeneity holds basically. Okay, the principle of homogeneity holds because y is increasing in a certain proportion, constant proportion, right? Now let us consider another equation. So you will see that this equation is the equation of line. This is the equation of line. But is this a linear system? Is this a linear? Okay, so that is the question. Okay, so if you have an equation which represents the equation of line, it doesn't mean that it would be a linear system. It may be non-linear also. So this is what written on the top. Sometimes equations that we think are linear turn out not to be linear because they fail the homogeneity property. Now let us see how it fails the homogeneity property. Now, okay, so in this equation, if you see here, if you draw the graph between y and x, if you draw the graph between y and x, okay, so now let us have uh, the graph here, okay, so now, so let us see. Now, in this case, when x is equal to 1, y is equal to 6. When x is equal to 2, y is equal to 10. Now, what you have done here, you have increased, you have doubled the what you say, input. It was 1, then you have doubled it and you made it 2. Okay, y is 6, y should be 12 here, it should also be doubled. If you have doubled, if you have increased the input by 2 times, your output should also increase by 2 times, right? that means that means y should be 12, but it is 10. It is not doubled. Like in this example, my dear folks, if you have x is equal to 1, y is equal to 4. You double the x, yani ki you make it 2, y is equal to 8. You double it, that is you make it 4, y is equal to 16. You double it 8, so y is equal to 32. So here, when you are increasing x each time by 2, factor of 2, your y is also increasing by same factor. But in this case, guys, let us see here, in this case, in the second equation, which is the equation of line, this is the equation of line. So in the second equation, guys, if you see, so let us draw a table here. So let us draw a table here. Let us write x and y. So if x is 1, y is equal to 6. Make x double twice. So y is equal to 10. Make x double 4. Y is equal to 18. But it shall be equal to, like I'll write here, it should be equal to 12. It should be equal to what you say 20. And make x 8, so y will be equal to 8 4s are 32 plus 2, it is 34, so it shall be equal to 36. So you can see here you are increasing, you are scaling x with a factor of 2, but y is not scaled with the same factor. So we will say that in this equation, homogeneity or scaling property is not true, right? So this is not a linear equation. This is not a linear equation, you can see. It is not a linear equation. So anything which seems to be a line is not every time linear, because all the systems are governed by certain equations. So these equations have to follow certain properties, and these properties are, for example, homogeneity property or scaling property, and also the property of superposition or additivity, right? So this was about homogeneity. So we'll see the two equations with the diagram. The first equation, y is equal to 4x, and here y is equal to 4x plus 2. So this is a straight line. This is a straight line, guys. but not linear, right? Okay, so I hope it is clear that how to identify from equation, from graphical representation, whether the given system is linear or not, right? Now let us come to the principle of superposition or additivity property. Additivity property itself is known as principle of superposition. Now what is principle of superposition? I'll try to make it clear with an example. For example, there is a system S1 which has some input X1 and it has certain output Y1. Let us say that in the same system S1, if you apply some input X2, it will have certain output Y2. Now, if you apply to the same system the combination of the two inputs, instead of applying them individually, if you add the two signals, two excitations, two inputs, and apply to the same system, so your system must give you an output which is equal to Y1 plus Y2. This is what superposition is. This is what additivity is. Right? So if y1 is the function of x1, y2 is the function of x2, so in that case, dear, the sum of these two input shall yield the sum of the responses, right? So this is what superposition principle is. If a system responds to the input x1 with the output y1 and it responds to the input x2 with the output y2, it will respond to the sum of the inputs with the sum of the outputs. It must give. Okay, I'll repeat this concept once again. If you have a system, if you apply certain input x1 to it, it will give you some output y1. If you apply the input to the same system, some x2 input, it shall give you y2 output. And when you apply the sum of these two inputs to the system, it shall give you some of the same outputs. Same output. Means, let us say let us say that by applying some value, if you have a system s1, let us say you apply x1 here, it gives you, let us say, 2. By applying some x2 to the system, it shall give you 4. But when you apply the two inputs, sorry, x1 plus x2 collectively combined to the same system, it shall give you 6. It shall give you 6. That means sum of these two, right? So this is what principle of superposition or additivity property is. Okay, so we can generalize this statement that an element or a circuit obeys the principle of superposition if the net effect of the sum of cause is equal to sum of their individual effect. Okay, so what is a cause? Cause is your x, the input, and what is its effect? Effect is the output. Cause and effect relationship. Cause is input and this is the response. That is output, right? That is the output. Okay, so these two principles are very important and are necessary for any system to be a linear system. So the superposition or additivity property has been explained with an example. For example, you have an equation y is equal to x. So let us say x is equal to x1. So you will get y1 is equal to x1 because of this equation. If x is equal to x2, you'll get y2 is equal to x2, right? Now, if you add these two equations, if you replace x with x1 plus x2, then y shall be replaced with y1 plus y2. Okay, so that means the net response of a system which is obtained by applying the sum of the inputs is equal to the sum of the individual effect as obtained by applying an individual input to the system. Now let me clear it in Hindi. जब भी आप किसी सिस्टम पे कोई इनपुट अप्लाई करते हैं, राइट, उससे कुछ आउटपुट आता है, आपने इनपुट चेंज किया, उससे कुछ आउटपुट आया, तो उस सिस्टम का जो टोटल आउटपुट है, टोटल रिस्पॉन्स है, टोटल इफेक्ट है, वो उन सभी आउटपुट का सम है जो आपको इंडिविजुअल इनपुट लगाने से मिला है उस सिस्टम पे। आपके किसी सिस्टम का जो टोटल आउटपुट है वो उन सभी आउटपुट का सम है जो आपको उस सिस्टम पे लगाने से, इनपुट, इंडिविजुअल इनपुट लगाने से मिला है, राइट? सो दिस इज व्हाट प्रिंसिपल ऑफ सुपरपोजिशन इज। नाउ so the net output is y1 plus y2. So if you add, we know that y1 is equal to x1 and y2 is equal to x2. So that means the sum of the responses is equal to the sum of the inputs. So if we add both the input, let us say हम दोनों input को add कर देते हैं, x1 plus x2 कर देते हैं, तो इससे भी हमें y1 plus y2 ही मिला, right? So दोनों equation, याना कि equation number 6 and equation number 7 both are same, both are alike. So this is what additivity property is, right? Now let us take another example wherein we have this equation. This equation is the equation of line, right? Now let us replace x with x1 plus 3, and so we will get y1, some output y1, right, which is equal to x1 plus 3. So let us draw it with a diagram. So this is a system x which has a constant input 3, and then you apply some x1 here, so you get y1. Similarly, on the same input s, you have a constant input 3 and you apply some input x2, so you get some output y2, right? Now the total response of this system, the total response of this system should be equal to what? Should be equal to y1 plus y2 when you add all the inputs. So what is the input here? This one and this one. This is the constant value, it is remaining unchanged, so x1 and x2. So that means you have a constant value 3 here, you have applied x1 plus x2. Now what you have done, you have applied x1 plus x2. The constant value 3 is always there, so you don't have to add it, okay? Now then y1 plus y2 is equal to, guys, y1 plus y2 is equal to x1 plus x2 plus 3. But if you combine these two equations, y1 and y2, so y1 plus y2 will give you x1 plus 3 plus x2 plus 3, which is equal to x1 plus x2 plus 6. That means the principle of superposition does not hold true. Why? Because what is principle of superposition? The total output of a system is equal to the sum of the output of the system obtained by applying the individual signals, individual inputs. Now you have applied the individual input here. It should give you x1 plus x2 plus x3, but what it has given by adding mathematically the two equations, x1 plus x2 plus 6, and these two equations are not identical, they have to be identical. When they are not identical, so we'll say that additivity property, or you can say principle of superposition, does not hold true. So this particular equation, no doubt this equation belongs to the equation of line, but this equation is not linear, not linear. Okay, so the summary of this lecture is a functional relationship is said to be linear if it obeys both superposition as well as homogeneity. That is additivity and scaling, right? Any element governed by such functional relationship is linear. That means if any element's behavior, or if any element is expressed by such equations, such mathematical relationships where the equations follow both the properties, homogeneity as well as superposition, so we will say that particular element is a linear element, right? Now, any circuit which is composed of linear element is a linear circuit. It is a linear circuit, right? Okay, when we scale an input by a factor m, the output of the system is also scaled by same factor. This is what scaling is, or homogeneity. Okay, and when the net output is produced, sorry, when the net output is produced by two inputs applied individually to a system is same when the sum of two inputs is applied to the same system. What does it mean? That you have a system, you apply one signal x1, you will get some y1. You apply some input on the same system x2, you'll get some y2. You'll apply some input x3 on the system, you'll get y3. But when you combine all these three inputs, x1 plus x2 plus x3, and you apply same on the same system, so it shall give you y1 plus y2 plus y3. So the total response is the sum of the individual responses obtained by applying individual signals. So this is what superposition is, right? So thank you guys, this was all about this lecture. I hope the things are clear to you. What is linear system, what is linearity, what is homogeneity, what is scaling, what is additivity, what is superposition. So thank you so much.